Welcome to this session of electronics. Today we are discussing about the fiber optics or optical fibers. We are living in the age of internet and everybody expected the fast access of the internet. And today the increasing ability to transmit more information over long distance more quickly has been expanded the boundaries of our technological development in many areas such as data network, wireless and satellite communication, cable operation, and in the broadcasting. Everybody wants the fast access of the information, and that is possible with the help of fiber optics. Before that, we are using the different types of the techniques for the transmission of data or the information from one place to the another place, and that is the wire communication. With the help of copper wire, the information can be sent from one place to the another place. Similarly, we are using the wireless communication, or through the wireless we can send the information from one place to the another place, and these two technologies have many drawbacks, and due to that the new emerging technology is developed that is known as the fiber optics, and the fiber optics is able to transmit the information with very high speed. Okay, so let us see the fiber optics. What is the fiber optics? Here the two words, that is the fiber and optics. Here the fiber means nothing but a thread, or it is a very thin wire, or it is wire like structure, and that fiber is made from the very transparent object like as a glass or the plastic. So remember that here the fiber is a transparent fiber, or fiber is a thread of transparent glass, and here the optics is related with the light, and fiber optics is nothing but the transmission of light through the very thin fiber or the thread. So the size of this thread or size of such type of wire is very thin, and which is same like as the diameter of human hair. There are the different types of the optical fibers. Some are single thread, and sometimes the number of threads or the number of optical fibers are put together, and the information means the light can be transmitted through the optical fiber for the long distance. So this is the optical fiber. Okay, single optical fiber consists of the core. Here the optical fiber, or this is the optical fiber, or this is the wire. which is made from the glass, and this is known as the core. And here the light is travel through this fiber, and here this optical fiber is not covered with the any protective layers. Therefore, here the light can be refracted from its boundary, and some light is refracted and some light is reflected and passing through that fiber. And when the light is comes out from the optical fiber, that is known as the loss of the light. So this is the optical fiber. Here this is also the optical fiber, but this optical fiber is covered with the another type of the material, and this cover is known as the cladding, and the internal structure of that fiber is known as the core. So generally optical fiber has the center part, which is known as the core, and the protective layer, which is known as the cladding. So this is the optical fiber. When we compare the optical fiber with the copper wire, you know that before optical fiber, the information can be transmitted or information can be sent from one place to the another place with the help of copper wire. Therefore, the copper wire is very popular. But today, the fiber optics replacing the copper wires, because the optical fiber have many advantages, and the very important advantage of the optical fiber is it is very less expensive, and due to that its price is very low when we compare with the copper wire. And the optical fiber is very thin, and they can have the very higher carrying capacity. The optical fiber are well suited for carrying the digital information, and there is no electricity traveling through the optical fiber. Therefore, danger of fire is reduced. When electricity is flowing through the any wire or through the cable, then there is the danger of the fire. But here in the optical fiber, the information is transmit or information is flow in the form of light. So this is the advantage of the optical fiber, and as the size of optical fiber is very small, therefore it is lightweight, and it takes very less space, and it is also the flexible, and the optical fiber is looks like this. Here this is the optical fiber. As you see, this is the center part, and this center part is known as the core, and this is the protective layer, which is known as the cladding. And here the cladding is used to protect the internal part of the optical fiber, and the information or the signal is transmitted through the optical fiber in the form of the pulses of light. So light can be flow from one place to the another place with the help of different paths like these are the different path of the flow of light from one end to the another end. Okay, and there are the three factors which can be affect the optical fiber, that is known as the attenuation, dispersion and bending losses. The attenuation happens when the light becomes dimmer. When the attenuation happens, then the light is dimmer and it travels through the optical fiber, and this causes the losses. Similarly, the dispersion is the corruption of signal due to the different spectral component of the light, and the bending losses is the loss of the signal due to the micro and macro bending of the optical fibers, like this. This is the micro bending, this is the macro bending, and due to that the light loss. Okay, and this is the traveling of light with the help of total internal reflection. Here the light without refraction, and here the light with refraction. There are the two way to flow the light. Okay, here there are the two different types of the fiber. This is the single mode fiber and this is the multi-mode fibers, and detail about the single mode and multi-mode fiber we are discussing in the next session. Okay, so this is the structure of optical fiber. Here the optical fiber consists of very thin fiber at its center, surrounded by the cladding. Here this is the cladding, and this center part is known as the optical fiber, and this center part is made from the glass. And the example of glass is made from the silicon dioxide, and here the small amount of the additive is added with the silicon dioxide, and that additive is GO, and that additive is added for the control of the refractive index. And most of cables are like this. This is the core, this is the cladding, this is the buffer layer, this is the strength membrane, this is the polyethylene. In this way the optical fiber is protected by the many layers. Okay, and these layers are protect the optical fiber from the moisture, from the chemical protection. So this is the structure of the optical fiber. Let us see the classification of optical fiber. The optical fiber is classified into the three groups according to the way of light propagate through the optical fiber, or according to the flow of light. The optical fiber is classified into the three groups. The first one is the multimode steps index fiber, second one is the single mode steps index fiber, and the third one is the multimode graded index fiber. And this is the multimode steps index fiber. Here multimodes, actually mode means the path, or mode means the way through which the light can be traveled from one end to the another end of the optical fiber. This is the optical fiber. As the name of this optical fiber is multimode steps index fiber, and multimode means the number of ways or the number of path for the light traveling from one end to the another end, that is known as the multimode. And here steps index fiber means nothing but, here index is the refractive indices of the optical fiber, as this is made from the light, this is made from the glass. Therefore the refractive index of flint glass is nearly equals to the 1.5, and the refractive index of air is equal to the 1. Okay, so the different material have the different refractive index, and refractive index decide the speed of light or velocity of light through that material. So remember that here the refractive index of this core, here the core is from this point to this point, and the refractive index of the core is equal to n1, and the refractive index of the core is the same. Okay, and this is the cladding. Cladding is nothing but the protective layer, okay, protective cover for this core or for the optical fiber, and the refractive index of the cladding is different. Actually here the refractive index of the core is higher than the refractive index of cladding. Okay, so this is the multimode steps index fiber, and here in this case the light travel from one end to the another end, and it occupy the different paths. Here the path number light number 3, this is the light number 3 or the light ray number 3, and it travel through this optical fiber in the straight way, and it can reach the output in very short time because it takes very less distance, therefore it can travel with very high speed. Suppose the speed of the each ray is same, but it takes very less distance, therefore it can reach at the output in very less time. And if you are looking towards the path number 3, ray number 3, and it takes more time to reach at the output because it it can travel through the optical fiber in the very long way. Okay, in this way these rays reach to the output at a different times, and we get the output for the long times. Suppose the input pulse is like this. Okay, so we expect that the output pulse is also the same like as the input pulse, but the output pulse is broadened. Okay, and this is due to the different modes of the lights, and such types of the mode is known as the dispersion modes. Okay, or this is known as the modal dispersion. Okay, so here the output pulse is wider. So this is the steps index multimode fiber. Next one is the single mode steps index fiber. In the single mode steps index fiber, here the fiber is same like as the multimode steps index fiber, and the single mode steps index fiber. Here the refractive index of core is same, and the refractive index of the cladding is different. So here from this point to this point the refractive index is same, and from this point to this point the refractive index is different. That is the cladding, refractive index of cladding and refractive index of the core is different. And here the refractive index change in the steps. Okay, and here the modal dispersion can be reduced or it can be removed with the help of single mode steps index fiber, because here only single light can be traveled from one end to the another end, and therefore due to that we get the output pulse, and output pulse is nearly equals to the input pulse, and therefore the modal dispersion is decreases here. Okay, so this is the single mode steps index fiber. Now let us see the third type of the optical fiber, that is the multi-mode graded index fiber. And this is the multi-mode graded index fiber. Means here the refractive index of this core is different at different point. Suppose at the center the refractive index is large, and when we go away from the center, then the refractive index is changing. Here the refractive index at this is Na, refractive index at this point is equal to Nb. Suppose the refractive index at this point is equal to Nc, and the here the refractive index Na, Nb, Nc are the different. Here the refractive index Na is larger than Nb, and which is also be larger than Nc. Means the refractive index change from the center. Okay, so here such types of the optical fiber is known as the graded index. Graded means the refractive index change very slowly, slightly from the higher to the lower. That is known as the graded index. Okay, and as you know that the refractive index decide the speed of light. Okay, if the refractive index is more, then the speed of light is less. If the refractive index is less, then the speed of light is more. Okay, so here the different path taken by the lights. This is the one way, this is the another way. But here when the light is traveling from one end to the another end, the light can travel with the same velocity. Okay, and when it reach at the output, both the rays reach the output at the same time, and therefore here the modal dispersion is reduced with the help of uh, multimode graded index fiber. Here the modes are different, means the path for the light are different, and this index, that is known as the refractive index for the core, is also the different. And in this way these are the different types of the optical fibers, that is the multimode steps index fiber, then the single mode steps index fiber, and this is the multimode graded index fiber. And the performance of multimode graded index fiber lies between the that of multimode steps index fiber. Actually the steps index single mode steps index fiber is used for the long distance, and such types of the multimode graded index optical fiber is used to transmit the information for the less distance. This is the difference between the different types of the fibers, or this is the classification of optical fiber. Now let us see how the light can propagate through the optical fiber. And here the light is nothing but the electromagnetic wave, and the speed of light is 3 into 10 raised to 8 meter per second when it travels through the vacuum, and its speed can be changed when the medium is changed. Instead of vacuum, when it travels through the glass, then its speed is slightly decreases. Actually in the air also the velocity of light is nearly equals to 3 into 10 raised to 8 meter per second, and this velocity is depends upon the frequency. However, the velocity of light propagation in medium depends upon the particular material, and it is always less than the velocity of light in the vacuum. Remember that velocity of light in the vacuum is maximum. When the light travels through the another medium, then its velocity decreases. And most of light consists of a different frequency rather than the wave with the single frequency. For example, visible light having the different colors, like as the blue and red colors, or blue and red light, and the blue light having frequency that is the 0.6 into 10 raised to 15 hertz, and for the red light the frequency is equal to 0.4 into 10 raised to 15 hertz. Okay, and therefore the different colors having the different frequencies. If we call the group of velocity of light wave through the certain medium, which is the phi, suppose the velocity of light of the different color which is traveling through the medium is equal to v, then the c by v is equal to n. Here n is nothing but the refractive index, and c is the velocity of light in the vacuum, and v is the velocity of light in the medium. And this ratio, velocity of light in the vacuum, ratio of velocity of light in the vacuum to the velocity of light in the medium is equal to the refractive index. Okay, so n is the refractive index. This ratio denotes the refractive index. When light travels through the medium, its wavelength changes but its frequency is not changed. And if lambda is the wavelength of light in vacuum, then lambda in material have refractive index of n can be found as like this. Suppose in the vacuum, lambda is the wavelength and lambda is equal to c by f. Here c is equal to velocity of light in the vacuum and f is the frequency of the light. Therefore lambda is equal to frequency, velocity divided by frequency. Similarly, in the medium, suppose the light traveling through the medium, its wavelength is equal to, suppose, lambda dash, and that lambda dash is equal to v by f. V is the velocity of light in the medium and f is the frequency of that light. And if you take the ratio of these two wavelengths, that is the lambda dash divided by lambda, that is equal to c by f divided by v by f, and which is equal to c by v. So this ratio lambda dash divided by lambda is equal to c by v. Or we can write lambda dash is equal to lambda into c divided by v, and c divided by v is nothing but the refractive index, and the refractive index is denoted by n1. So lambda dash is equal to lambda into n1. Okay, it may be noted that the refractive index of material varies with the wavelength of light when passing through the medium. For example, flint glass has refractive index of 1.66 at lambda is equal to 400 nanometer. When the wavelength is equal to 400 nanometers, then this flint glass having the refractive index which is equal to 1.66. Similarly, for the 700 nanometer, refractive index for the same glass is the different, that is equal to 1.62. Here let us see one example, and this example is compute the velocity and wavelength of light of frequency f is equal to 0.5 into 10 raised to 15 when the traveling through the glass having refractive index of n1. Here we have to calculate the velocity and wavelength of light. Here the frequency is given, frequency is equal to 0.5 into 10 raised to 15 hertz, and refractive index is also the given, and we know that we can compute the velocity and wavelength. We know these relation. What is the relation for the velocity? Velocity is equal to speed of light divided by refractive index, and therefore here we can substitute the value of C is equal to 3 into 10 raised to 8 divided by N1. N1 is the refractive index, which is equal to 1.5, and this is equal to 2 into 10 raised to 8 meter per second. Similarly, we know the wavelength. Wavelength is equal to velocity divided by frequency. So here lambda is equal to V by F, and therefore that is equal to 2 into 10 raised to 8 divided by 0.5 into 10 raised to 15, which is equal to 400 nanometer. So here we can calculate the velocity. Velocity is equal to 2 into 10 raised to 8 meter per second, and the wavelength is equal to 400 nanometer. So in this way we can calculate the velocity and wavelength. Thank you for watching this video.